Okay, guys, over the next few days, we are going to be talking about the key features of graphs. So, just learning about how to explain the different characteristics of a graph, and we'll break it into 2 days, and then on Wednesday, we'll throw it all together. So, um, domain and range are two key features that you learned about last week. We're going to learn about a few more today. If you zoom in on those first few warm-up problems, though, I want you to give those three a shot just as review from last week. So go ahead, pause the screen, and try those first few warm-up problems. In this first example, you should have plugged in -7 in place of x. Keep in mind that when you square a negative number, it becomes positive. -7 squared is -7 times -7, making it positive 49. If you plug that into your calculator, please make sure that you wrap that -7 in parentheses. Otherwise, if you leave the parentheses off and just write -7 squared, it'll tell you it's -49, which you mathematicians know is incorrect. On example number 2, you should have plugged in -2 into two spots, right here and right here. When you plug in -2 and cube it, -2 cubed is -8 because it's -2 times its own self 3 times. Again, if you plug that in the calculator, please make sure to wrap it in parentheses. -2 times -2 gives you positive 4, and then add and subtract left to right. Make sure you're able to write your final answer as an ordered pair, -2, -3. That means if we graphed this line, then the point -2, -3 would lie on that graph. For your final warm-up problem, you should have plugged in 4x minus 1 in place of x. Make sure that when you plug it in, you put parentheses around it because that -3 that is multiplied out front is distributed to both terms inside, resulting in -12x plus 3 minus 4. Combine your like terms here, the 3 and the -4, to get -1. If you were going to write this one as an ordered pair, it would look kind of weird, but you could write the x value is 4x minus 1. The output would be -12x minus 1. Now let's take a look at some new content. The first two vocabulary words, or the two characteristics that we're going to look at, are increasing and decreasing. And they sound exactly like you would think. So I want you to take a second and think about what you think about when you hear the word increasing. Fill in your ideas right here. It is likely that your prior knowledge of the word increasing goes right along with the definition of increasing on a graph. The graph is increasing where the graph goes up. In other words, it is wherever the graph has a positive slope. So as x goes up, y is also going up. Visually, this is what it will look like. In this bottom left portion, where you draw a picture, I want you to have your x and y plane, and let's put a graph on there. Let's have it look something like this. The graph is increasing, where if you imagine you're like riding on a roller coaster, imagine it's the part where you're clicking up to the top. So the graph would be increasing in this portion, and the graph would also be increasing in this portion as well. Once you've drawn that, I would get a highlighter out and highlight those portions of the graph where it is increasing. Again, here and here. When you are describing the portion of the graph that is increasing, you always write in terms of x. In other words, you're looking at the x-axis, kind of like domain. So you put your x in the middle, you surround it with less than signs. You talk about the smallest x, where it is starting to increase, and then you continue until the largest x, where it stops increasing. So for example, Let's say that this was 3. We would say that this graph, this right portion of the graph where it's increasing, put your X in the middle. It starts at 3, and then it continues to the right forever. So from 3 to infinity, it is increasing. We'll continue doing some practice in some future problems. Decreasing parts of the graph are the exact opposite of that. So the definition of where the graph is decreasing is where the graph is going down. That's like in layman's terms, where the graph is falling. In other words, it's where the graph has a negative slope. Let's draw another picture. Similar graph, draw your X and Y axis. We're going to put a similar graph on there. The decreasing portion of this graph would occur where the graph is falling. Imagine if you're on a roller coaster, it'd be the part that you're going downhill. Highlight that portion in the middle to show where the graph is decreasing. Just like with increasing portions of the graph, you'll write in terms of X. In other words, don't even look at the Y-axis at all. You put the smallest X where it's decreasing on the left-hand side and the largest X on the right-hand side. So let's say on this graph, for example, that this is -2 and this is +3. If we were trying to describe where this graph is decreasing, put your X less than on either side. It starts at -2 and continues to 3. That is the portion of the graph where the graph is falling, where it has a negative slope, or where it is decreasing. The next vocabulary word that we're going to learn about today is X-Intercept. The definition of an X-Intercept is the point or points, so I'm going to put a little S in parentheses, where the graph touches or crosses the x-axis. Once you get that copied down, let's draw another picture. Let's put our function on there. Let's say that this is at 4. Let's say this is at -5. When you're writing your x-intercept, you write it as an ordered pair, whatever the x-intercept is. And then if you're a point on this x-axis, think about what the y value is. You're not going up or down at all. You're just staying there. So it is 0. So for example, if we are going to describe this x-intercept on the right, we would write it as an ordered pair, 4, 0. If we were describing this x-intercept, we would write it as -5, 0. So key idea, you write as an ordered pair. In other words, please do not just say the x-intercept is 4 or -5. Make sure that you are writing it as a point. Cool beans? Let's take a look at Y-intercept. The Y-intercept is the point or points on graph where it touches or crosses the y-axis. Remember, the y-axis is the one that goes up and down. So let's draw a picture. Let's pretend that that is at 5. To find it, you're going to write your answer as an ordered pair. So the y-intercept will go in the y location of the ordered pair. Now, think about if you're on this point right here. What is your x value going to be if you don't go right or left at all? If you're thinking 0, you're exactly right. So if we are going to describe this y-intercept right here, we would write it as the point 0, 5. Keep writing it as an ordered pair, not as just a number. The last vocabulary word we are going to look at on the second page is maximum and minimum. They are what they seem like. Maximum is the highest point of the graph. Minimum is the lowest point. However, there are 2 types of maximums and 2 types of minimums. So I want you to break it apart like this. There's something called the absolute maximum and the relative maximum. The absolute max is the absolute highest point of the graph. It is the highest point of the graph. The relative max is the highest point around. So in other words, if you're this point, if you're a relative max, if you look to your left or your right, you'd be the highest around, but you wouldn't be the highest of the entire graph. So let's get a visual of this so you can see what I'm talking about. Let's draw a picture here. Go ahead and put your X and Y axis on there. And let's draw something that looks like this. This point on the left is a maximum, as is this point on the right. The point on the left is an absolute maximum. The point on the right is a relative maximum. The point on the left is the highest point on the graph, making it the absolute maximum. The point on the right is a relative maximum because it is a high point in its neighborhood. It looks to its left, it looks to its right, the points around it are lower than it, so that makes it a relative maximum. But it is not the highest point on the graph. And then when you write it as an ordered pair. So you write as an ordered pair. We'll practice that in a minute. Similarly, you can have a relative absolute and a relative minimum. An absolute min is the lowest point on the graph. On the other hand, a relative minimum is the lowest point in its neighborhood, so the lowest point around. In other words, if you're a relative minimum, you look to your left, you look to your right, and all the points around you are higher than you, but you're not the lowest point on the graph. Let's draw a picture of this so that we can get it through our heads. Put your X and Y axis down there. Let's make something that looks a little bit like a W. Take your highlighter out or a different color and highlight these 2 points. These are both minimums, but they are different types of minimums. The one on the left is the absolute minimum because it is the absolute lowest point on the graph. The point on the right is a minimum in its neighborhood. It looks to its left, it looks to its right, and it's lower than all the points around, but it is not the lowest point on the graph. So we would just say it is a relative minimum. To write it, you write as an ordered pair. Okay, we're going to take those 6 vocabulary words along with domain and range, which we learned about last week, and we are going to do a couple examples together. I would encourage you to get a highlighter out and work through these like different pieces using different colored highlighters. So as some review from last week, you'll remember that domain is what the x values of the graph can be. To write the domain, you write with an inequality. You're writing it in terms of x. You look at your graph and you look at the x-axis and you think, okay, it's all the x values that the graph can be from the left part of the graph to the right part of the graph where it ends. Now remember, if there's an arrow on the graph, you have to take into consideration that that graph could be going forever to the left. So on the left-hand side, the x's go toward negative infinity. That graph is not stopping. As it continues on and on, it's going up, but it's also going forever to the left. So we call those numbers forever to the left, negative infinity. The x's stop when they get to 10. When they get to 10, they stop, and it's a solid bubble, so we should underline that inequality sign. Let's do the same thing with the range. The range, we look at the y values. So set up your y inequality. And let's look on the graph where the graph starts at the bottom of the graph on the y-axis and where it stops at the top. The smallest y value that the graph can take on is this -5. Because it's a solid bubble at -5, you should underline that inequality sign. As you continue up, you might think that the graph stops right here at +8. However, if you look to the left, you'll see that there is an arrow on that graph. Remember, it's not only going left, it's also going forever up. Forever up, we call positive infinity, those numbers that get larger and larger and larger. That is your review of domain. Let's try to find the x and y intercepts. The x-intercept is where the graph crosses the x-axis. We write them as ordered pairs. Look at your x-axis. If it helps you, label your x-axis. Count how many times the graph crosses or touches the x-axis. You should count 4 times. That means we're going to have 4 ordered pairs here. You do not write your x-axis as just a plain number. You write it as an ordered pair. The first x-intercept is over here at -8. That is the point -8, 0. The next place it crosses the x-axis is at -5. We'd write that as -5, 0. Record the 2 other ones as well, 4, 0, and 10, 0. Even though it just touches the x-axis at 10 and doesn't cross through, that is still considered an x-intercept. Let's continue on with y-intercept. The y-intercepts are where the graph crosses the y-axis. The y-axis is the axis that goes up and down, so you'll notice that it only crosses once. Write that as an ordered pair. In the next piece of the graph, we're asked to find the maximum and the minimum. Find the highest point on the graph. That maximum point on the graph, write as an ordered pair. You also need to designate whether it is a relative max or an absolute max. Now, remember that this graph on the left-hand side has an arrow, meaning it is going to continue going up and up and up. Does that mean that this point is the highest point on the graph? You should be thinking no. Because of this arrow that continues on to the left, this is considered a relative maximum. Let's do the same thing with the minimums. You'll notice that there are 2 minimums on the graph. We have this point down here and this point. So we have -7, -5. That -7, -5 is the lowest point on the graph. So you should call it an absolute minimum. The point 7, -3 is the lowest point in its neighborhood, but it is not the lowest point on the graph. So you should designate that a relative minimum. The last part of the graph that we'll look at is the area where the graph is increasing versus decreasing. I'm going to highlight the area of the graph where it's increasing in orange. I would encourage you to highlight it a color as well. Increasing means it has a positive slope. You should find two places of the graph where it's increasing. Here and here. We will write those areas of the graph where the graph is increasing with two separate inequalities. So set up your inequality twice to describe the two pieces of the graph that are increasing. Remember, you do this in terms of x, not in terms of y. So in other words, do not look at the y-axis at all, look only at the x-axis. This place where the graph starts increasing is at an x value of -7. It continues increasing all the way to that star up there. That x value is -2. So in between -7 and -2 on the x-axis, the graph is increasing. You'll now set up a totally different inequality for the next portion of the graph. This second orange section where it's increasing starts at +7 and continues till 10. Remember, we are not looking at the y-axis when we determine those areas where the graph is increasing, only the x-axis. Let's do the same thing for where the graph is decreasing. I'm going to highlight with a different color. Let's use blue. You'll notice I've highlighted two different sections. That means you're going to set up two different inequalities. Go ahead and set them up so you have them ready. Let's look at this left portion of the graph. The graph is decreasing for all these negative x values. It's falling. Those negative x values we call negative infinity because the graph has an arrow on it. It continues going down until the x value of -7. So in between negative infinity, stopping here at -7, that is a decreasing part of the graph. It starts decreasing again in this second highlighted region. That x value where it starts decreasing is -2, and it continues until +7. Pause and re-listen to any portion of that might have been confusing for you before we go on to our next example. For this last example, I would encourage you to pause your screen and try to get through as many of these different portions as possible. You can even leave blank the ones that you might have been stumped on. I'll give you all a second to pause the screen, try those out on your own. For the domain of this graph, you should have looked at the x-axis to determine what your x values are stuck in between. You'll notice that we have an arrow on the left and an arrow on the right. The arrow on the left is reminding us that the graph goes forever left and forever down. The arrow on the right is reminding us that it goes forever up and forever right. So in terms of left and right, it's going forever to the left, that's negative infinity, and forever to the right, that's positive infinity. Similarly, our range, we look at the y-axis, so set up your y inequality. You might think that the graph starts down here at 7, -6, but remember, arrow goes down, arrow goes up. So it's going forever to the bottom of the graph, which we call negative infinity, forever to the top, which we call positive infinity. Pause and correct those if you might have missed them. The next thing you need to define were your x and y intercepts. Please make sure that you're writing those as ordered pairs. You should have 3 different ordered pairs for your x-intercepts to check out the 3 different times the graph crosses the x-axis. That first one crosses at -8, so we write it as -8, 0. Second one crosses at 4, so we write that as 4, 0. And the last one, you should have had 9, 0. The y-intercepts, there's only one. You should have written that as 0, 5. When you're looking at the maximum part of the graph, hopefully you zoomed in on this point up here, 1, 7. You need to designate whether it's an absolute or a relative maximum. Remember that this graph is continuing upwards. It is not stopping when we look to the right of that graph. So that means that the point 1, 7 is not the absolute maximum of the graph. It is a relative max. Similarly, if you look at the bottom of your graph and look at this point, 7, negative 6, it is not the lowest point of the graph because the graph is continuing down and to the left, designated by that arrow. So this is a relative min. The last thing that we'll look at are the areas where the graph is increasing versus decreasing. I would encourage you to use highlighters in this step. The graph is increasing where it looks like it's going uphill. That occurs in 3 different regions. So you should have 3 different inequalities when you talk about where the graph is increasing. This left portion, we look at the x-axis, it's going forever to the left, so we call that negative infinity, and it stops increasing at the x value of negative 6. The second portion starts at negative 2 and continues until the x value of positive 1. Please do not look at the y-axis when you're finding the area where it's increasing or decreasing. So we have negative infinity up to negative 6, negative 2 to 1, and then our last one starts at an x value of 7 and continues till the x values of positive infinity. Take a different highlighter color if you have it available. And let's look at where the graph is decreasing. It's falling in this portion here. We're going to write that in terms of x again. Since it's only decreasing in one region, we only need to write one inequality. That x value where it starts falling is at an x value of 1, and then it stops falling at the next value of 7. Last thing we need to look at is where the graph is constant. Constant means there's no change. So that's this flat portion right here. You'll still write it in terms of x. It starts becoming constant at negative 6 and stops at negative 2. You will have some examples on your notes, on your homework that look exactly like these, where you're practicing each of those vocabulary words. Go ahead and give it a shot, and I will answer questions as you have them.